Okay, so we just did atria and the ventricles. Yeah, let's move on to dietary intake and urinary iodine level. So, did this big study in the UK. Well, I guess it was big. Doesn't say how many people were involved, but it was just school-age girls, or girls between 14 and 15, which obviously are school age. So I wonder why it was only girls. That's another question. So we have the excretion of the urinary iodine level for girls that drank no milk at all, occasionally 1 cup, and more than 1 cup a day. It doesn't say this could be 10 cups. Didn't really say. I wonder. Interesting to see why that was. And this has, the bars, the range. It looks like the ranges. It doesn't say exactly, but it gives the median value. So I believe this is the just the range. And remember, the median is the number in the middle. Okay, so that must be, I don't know, the quartile range. And so whatever number was right in the middle, that's where that line is. So this first question talks about values from 50 to 99, which I kind of highlight here, almost 100. If you're within this range, you're considered to be a mild iodine deficiency. So figure out, remember, deduce, figure out based on the facts, based on the graph, which is your data, the effect of milk intake on the iodine status. So as we can see, we see kind of a gradual increase, right, in this excretion of iodine. The more milk that was taken in. So the more milk taken in, the higher the iodine levels. For all the girls that drank no milk, everybody was iodine deficient, whereas the other groups, some of the groups got above the deficiency level. But another thing is, no matter what kind of milk intake, if you look at the median, everybody was iodine deficient at that median level. Okay, so in all groups, the median value is mildly deficient. So milk may not have that big of an effect, because you have a lot of milk, doesn't, for the overall effect, get you out of that iodine deficiency. And then I kind of made a note of this. You kind of get a decent gain from none to 1 cup a day, but it kind of peters out here. Our graph kind of goes up and then starts to kind of plateau when you come to over 1 cup a day. So maybe the magic number is 1 cup a day. Above that, there's not a whole lot of effect. So why do you need iodine? Well, let's get into it here. So outline, you absorb it, and it's used by the thyroid, which is in your neck here. This is your thyroid gland. It's used to make thyroxine, which is an important hormone for pretty much everything, as you can see here. And if you lack iodine, you get this condition called goiter, which is common. You probably see people that have it. If you look around, people you talk to. And thyroxine, you can also just think about it. It's used to regulate your metabolic rate, and that can have an effect on how hot or how cold you feel. Because the higher your metabolic rate, normally the hotter you feel. And let's see, growth hormones. Examples of peptide hormones. Explain the mechanism. So how does it work? So peptide hormones do not enter the cell. They attach to a special protein on the outside that's specific just for that hormone. And that binding leads to all sorts of cascades. So the hormone will land on the surface, and then in here you'll have a whole bunch more actions taking place, cascade. Cyclic AMP is something that we looked at recently. And usually these enzymes are either inhibited or activated using this type of regulation. One of the main things that happen if a patient has emphysema, this disease, so basically the air sacs break down. Instead of a bunch of tiny little air sacs, you have one big air sac, and that's a problem because that really reduces the surface area. So that's going to reduce the ability to absorb oxygen and the loss of elasticity. So lower absorption. You can't absorb it. So what do? Treatment. You see people carrying oxygen tanks. Maybe you have a relative. That's what's going on there. Their lungs just aren't efficient enough, so they need to have increased levels of oxygen. They can be taught breathing techniques to improve the amount of air they can bring into their lungs. There's chemicals or drugs that can dilate their bronchioles, including inhaled steroids, lowering inflammation. That's what steroids do. Those of you with allergies, you might already be taking an inhaled steroid. The nasal spray does that, or lung surgery or lung transplant. All right, dissociation curve. So you need to. The one that was on there is this dark line. So it wants you give you this scenario. You're exercising or whatever you're doing, you're going to have an increased metabolic activity. You're going to have more CO2 in the blood. You're also going to have a higher need for oxygen. So on the graph, I want you to draw the oxygen dissociation curve during intense exercise. So what will happen is this is called the Bohr shift. This line will shift to the right, which means you're going to get less oxygen saturation in the blood because it's going into the cells. So you want to draw this shift to the right. And that's going to allow more oxygen to be released out of the blood and into the cells. So remember, CO2 in any liquid creates carbonic acid. That's going to lower the pH of the blood. When we talk about lowering the pH, in this case, you're starting about 7.5. It's going to make it more acidic. So it might get down to 6.5, 6.2. That lowered pH decreases the affinity of the hemoglobin for oxygen. Less affinity, less likely to grab onto it and hold it. And that's going to get more oxygen to the cells. And this is called the Bohr shift. Yeah, like I have written right here, the Bohr shift. Oh, and the last question, here we go. Yeah, this is a big one, 6 points. So we should always try and do, when you look at 6 points, the minimum you want is 6 ideas, but if you can put down 8 or 9 ideas, go for it. Because as long as the ideas don't conflict with each other, like directly contradict, it can help you earn more points. So, erythrocyte, remember that's red blood cells. So, hemoglobin is that important protein. So, red blood cells rupture when they get to the end of their lifespan, about 120 days. They're absorbed by phagocytosis by Kupffer cells in the sinusoids of the liver. I was getting deep into liver tissue biology. So hemoglobin, look, hemoglobin, it gets split into hemo and globin groups. The globin, those are proteins, those are amino acids, made of amino acids that can be recycled. back out into the blood. And then heme groups, that's the actual iron. It can be recycled into iron, which the liver can store, or it can be released as bile pigment when there's too much. Now, what makes poop brown is that iron color from the breakdown of your red blood cells. Fun fact. Yeah, and that extra iron is basically released as bile. So there you have it. That's paper 3, 20% of your grade. Biggest thing, well, one of the biggest thing is to do all of section A and then skip to option B. Don't spend any time perusing option A, B, and C.